Hello friends, welcome to Math Solution Academy. Now we talk about linear algebra. It is very important topic for any PhD entrance examination such as NET, GATE, NBHM, etc. So it is very important to prepare these topics carefully and I solve here a problem in GATE 2017. The problem is if U and V are the null space of 1 1 0 0 0 0 1 1 and the matrix 1 2 3 2 0 1 2 1 respectively, then the dimension of the subspace u plus v is equal to. The question is u is a null space of this matrix and v is a null space of this matrix. First of all, let a equal to 1 1 0 0 be a matrix and 0 0 1 1 be a matrix. First of all, we let A is matrix and B is a matrix. 1 2 3 2 and 0 1 2 1. And by the given questions, that is U is a null space of A. That means U equal to x belongs to R to the power 4 such that x equal to 0 and V equal to y belongs to R to the power 4 such that By equal to 0. So x equal to 0, this imply 1 1 0 0 0 0 1 1 into one column vector x1 x2 x3 x4, where x equal to x1 x2 x3 x4 be an column vector in R4, and this becomes 0. This imply x1 plus x2 equal to 0, and from the second we get x3 plus x4 equal to 0. So this imply x2 equal to minus x1 and x4 equal to minus x3. So in that case the vector becomes x1 x2 x3 x4. This becomes x1 minus x1 x1 minus x1 x3 minus x3, and this is x1 into 1 minus 1 0 0 plus x3 into 0 0 1 minus 1. And so the where x1 x3 are real numbers, so that's why u equal to the linear span of two vectors, say alpha beta, where alpha is a vector 1 minus 1 0 0 and beta is a vector 0 0 1 minus 1. So u is a linear span of alpha beta, that is u is a vector space generated by these two vectors alpha and beta. Similarly by equal to 0, this imply 1 2 3 2 0 1 2 1 y1 y2 y3 y4 equal to 0. So that's why this imply y1 plus 2y2 plus y1 y2 3y3 plus 2y4, this equal to 0, and y2 2y3 plus y4, this equal to 0. So that's why, and from this we get y4 equal to minus y2 minus 2y3. So we put y4 equal to in this case, so this becomes 2y2 plus 3y3 minus 2 into y2 minus 4y3, this is 0. So this becomes this and this cancel out, so this becomes 3y3 minus y1 minus y3 equal to 0. and this became y1 equal to y3, and from 4 y4 equal to minus y2 minus 2y3. So that means y1 y2 y3 y4, this becomes y1, y2 means y2, y3 means y1, and y4 means, and this is minus y2 to y1, since y1 equal to y3. So this becomes minus y2 minus 2y1, and so we get y1 into 1 0 1 minus 2, and y2 equal to 0 1 0 minus 1. So v equal to linear span of two vector gamma and delta, where gamma is a vector 1 0 1 minus 2, and delta is a vector 0 1 0 minus 1. This is two vector. So therefore use a vector space generated by two vector alpha beta, where alpha and beta are defined, and V is an vector space, V is an also vector space generated by two vector, this and this. And now u plus v is equal to uv, where u belongs to capital U and v belongs to capital V. This is also an vector space. U plus v is also a vector space, and dimension of u plus v equal to dimension u plus dimension v minus dimension of u intersection v. So now we try to find dimension of this. Now friends, since U is a vector space generated by the two vector alpha and beta, and V is a vector space generated by two vector gamma and delta, so if alpha beta gamma delta is be linearly independent, then U intersection V is equal to phi, because if these are linear independent, these four vector is linearly independent, then U and V, then no vector in U belongs to V, and vice versa, because if this is linearly independent, then no vector in this vector space not belongs to this. If any one vector in U belongs to this vector V, then this is not linearly independent. So if this is linearly independent, then U intersection V is equal to phi. Otherwise, now we check if alpha beta gamma or alpha beta delta or alpha gamma delta or beta gamma delta. Now we check any of these four is linearly independent or not. If all of this linearly independent, then any one of say if say any one of these vector space belong to this vector space and vice versa. So in that case, U intersection V is a vector space of dimension 1, because if this is 4 are linearly independent, but this is linearly dependent, but if these 4 are linearly independent but this is linearly dependent, then any vectors in that case, if these 4 holds and this is linearly dependent, then any one vector in this vector space belong to this vector and vice versa. So therefore in that case, dimension of U intersection V is an vector space of dimension 1. And now we check we find here alpha, beta, gamma, delta. Alpha is 1 minus 1 0 0. Here beta is 0 0 1 minus 1. Gamma became 1 0 1 minus 2, and delta became here delta became 0 1 0 minus 1. And now we find the dimension of this. Now we find this is linearly independent or not. So in that case, we just transpose of each vector and replace it in a matrix. So we get, so from first vector we get this, from second vector we get this, from third vector we get this, and from the fourth vector we get this. You may also take the first column vector, the first vector in first column vector, second vector in second column vector. This is similar. And now we find the dimension of this matrix. And now we first, and we use the row operations. So this is 1 minus 1 0 0 and 0 0 1 minus 1, and now we get R3 minus R1. So this becomes 0 1 1 minus 2 and 0 1 0 minus 1. Now again we operate. Then this is this is the leading coefficient of second row, and so first we read that, and secondly we 0 1 0, and this is minus 1. So first we take R3 minus R2, and secondly, and the remaining part is 0 1 0 minus 1 and 1 minus 1 0 0. And now see that these two rows are identical, so we cancel out one row, and from here we get, this is a leading coefficient of third row, so this is 0 1 0 minus 1, this is 0 0 1 minus 1 minus 1, and this is 1 0 0 minus 1. So this is our reduced matrix, and this is R1 minus R3, and we see that the dimension of this is 3. So the dimension of this matrix is 3, and dimension, since the dimensions the rank of this matrix is 3, so the rank of this matrix is 3. So since the rank of this matrix is 3, so any three vector from this 4 vector are linearly independent. So that's why U intersection V is an one dimensional subspace, and that's why dimension of U plus V is equal to 3. You directly find this. First of all, you find these four vector and put there in a matrix and find the rank of this matrix. If the rank of this matrix is n, then the dimension of this is n. The dimension of this vector space is equal to the rank of this matrix. The dimension of this vector space is equal to the rank of this matrix. So you easily find that, and you cannot calculate these questions. You first of all you find these four vectors and put in a matrix and find the rank of this matrix. The rank of this matrix become the dimensions of this vector space. Thank you.